Hi, in this lesson we are going to look at type conversion. When we say type conversion, it is converting one data type to another data type. Okay, in this one we are going to look at various conversion across all primitive data types. Because we have seen primitive data types in great detail, this lesson is going to be very easy. Okay, without any delay, let's get started. Okay, so we know the range of different primitive data types. For example, byte can hold a maximum value of 127, short 32767. So the range increases when we move from byte to long. So is the case with floating and double. Double has a double precision, meaning the precision of double is greater than that of float. If you see, float can have up to 6 to 7 significant decimal digits, but double can have up to 14 or 15. Okay, so we know the ranges and we know which is having lower range and which is having higher range. Okay, so any variable of type byte can be assigned to short, integer, long, because short, integer, long has greater range than byte. Similarly, short can be assigned to integer and long. Int can be assigned to long. So in these cases, there is no problem because the one we are assigning to has a greater range. Similarly, if you assign float to double, there is no loss of precision because double has greater precision. Okay, let's look at these things in code. Okay, so here I have created variables of all the primitive types. Boolean cannot be converted to any other data type. Boolean is Boolean. Okay, so Boolean, it has a value of true and false, but it cannot be converted to either char, integer, or floating point. Similarly, characters, we want to treat them as characters. So we don't want to know whether we can convert them to other integer types. So now the conversion is restricted to whole numbers and floating point numbers. Okay, let's divide this conversion into two categories, mainly two categories. One is type conversion within whole numbers and type conversion within floating numbers. So first we will look at type conversion among these four data types, then type conversion among these two data types. Okay, that is within. After that, we go ahead and look at the type conversion across, like converting from integer value to floating value or from floating value to integer value. This is very easy. Pay a little bit more attention and you will understand it very thoroughly. Okay, let's discuss within whole numbers, the conversion within whole numbers first. Okay, as I have said before, byte is having a maximum value of 127. It can be always assigned to short, integer, and long, so there is no problem. So the conversion here is called implicit conversion because you don't need to do anything, right? Byte will be converted to short, int, long. So similarly, short can be assigned to integer and long. Integer can be assigned to long. This is because the range of left side variable is more than the range of right side variable. Okay, similarly, we have seen this floating point can be always assigned to double. Okay, now if we come in a opposite direction, okay, for example, if you want to assign a short value to a byte value, so obviously short value range is greater than that of byte, so compiler won't allow you to do that kind of assignment. In this case, you have to explicitly convert short to byte. Similarly, you have to explicitly convert from int to short and byte. If you are assigning long, then you have to explicitly convert it to int, short, and byte. Okay, so if there is no explicit conversion like this, so what happens is compiler is going to give you compilation error. It's saying possible lossy conversion from long to int. Obviously, long can hold a value of 20 billion, but it cannot be held in integer. So there is going to be some loss of value, right? So in these cases, you have to tell it, okay, compiler, I know what I am doing. I know the range of values in this particular scenario, that the long variable is holding is within the range of integers. So we are telling the compiler, even though I have a long variable here, I know the value inside that variable can be accommodated in integer. So please convert it. We are telling compiler very explicitly, so that is the reason it is called explicit conversion. Similarly, if you are converting from double to float, we have to explicitly tell the compiler, okay, there may be loss of precision because double has double precision, but that is okay in this particular scenario. I want that to happen, so I am explicitly telling you, go ahead and convert from double to float. Okay. Let's see with a simple example. Okay, so these are integer literals, as you know. So 120 is the integer value, so is 20,000. So if we explicitly cast 120 to byte, I can create a variable with value of 120, but it is okay to directly write this as a literal. Just to keep it simple, I am using the literals. So 120 is a valid byte value, right? So when it is explicitly converted to byte, it is going to be 120, but 20,000 cannot be represented in byte. So in this case, the result that you get is not what you expect because it can't be represented there. So let me execute this and we will see for ourselves. Okay, so first one is 120 converted to byte, fine, but integer 20,000 when converted to byte, you are getting a 32 value. So whenever you are doing explicit conversion, make sure you know what you are doing. The first thing should be the value should be within the range of the targeting type, in this case byte. Otherwise some rounding, not rounding, truncating and all those things happens and the result may not be what you expect. So that is all about converting within whole numbers and within floating numbers. Okay, so then we are moving across types, like we are moving, we are changing from whole point to floating point and floating point to whole point. Okay, here the things are very easy. Okay, whenever you are converting something from floating type to integer, this is always explicit cast. Why is it so? So for example, consider a simple floating value or a double value of 1.2. It has a fractional part of 1.2 which cannot be saved in an integer value. So whenever you convert something from floating point to integer type, the floating value will be truncated. So there is always going to be loss of precision or value, right? So you have to always convert explicitly. Compiler will not allow you to convert from floating point to integer type unless you explicitly cast it. So very simple. When we deal with integer type to floating point, there also we have seen that these floating point numbers, they can't accurately represent all the values. They represent only approximate values. So in case of floating point, it is only approximate up to 6 or 7 digits, but in case of double, it is very approximate to 15 or 16 bits precision. So whenever you are converting from integer to float, there is always going to be loss of precision, except one scenario, that is when you are converting from integer to double or anything less than integer to double, because double has a greater precision, like 15 or 16 bit precision. So this case it won't lose any value, but in all other cases, like anything to float will lose precision. Okay, but anything to not float, anything to floating point, any integer type to floating point will result in loss of precision, except when you are converting integer value to double value. Okay, that is all we have about conversion. We have covered all data types. We don't want to cover boolean and char because boolean anyhow cannot be converted. Char we want to treat it as character, not as a number. Okay, let's see the same thing in an Excel sheet. Okay, so the way I explained is in the previous example in the NetBeans, we have 4 types, right? First thing is at the higher level within integers and within floats. Then we have looked at across, like converting from integer to floating point or from floating point to integer type. So first look at the things in the same order. Okay, whatever the way we have looked at in the program, we will look at the same way. Okay, so within whole numbers, okay, so byte to byte no conversion, short to short no conversion, int to int no conversion, long to long no conversion. So this diagonal will be always not applicable. And anything above, like byte to short, okay, implicit conversion, we don't need to do anything. So short to int or byte to int, implicit conversion. So next, integer to long, implicit conversion, right? Or short to long, implicit conversion, byte to long, implicit conversion. So long can have a very high values. So coming to downside of not downside, the lower values of this diagonal not applicable. Anything will be explicit cast. For example, short to byte, explicit cast, into byte, explicit cast, long to byte, explicit cast. So this is very easy to remember, very easy to understand. Similarly, coming to float to float not applicable, double to double not applicable, and double to float you have to cast it, but float to double it is implicit. So we are done with within, right? I mean within whole numbers and within floating point numbers. So we are done with that kind of conversion, type conversion. So let's look at the other way, like converting across data types, like integer numbers to floating point numbers. First we will look at floating to integer. We have said that whenever you are converting a floating point, something like 1.2 to a integer, the fractional part is truncated, so there is always going to be loss of data. So it is always explicit cast. And coming to converting from integer type to floating point type, it is always implicit conversion, because this floating points has a very wider range. Even a long value can be represented by a float value, because you have 10 to the power of something, right? So just by writing 10 to the power of 13, 14, 15, you can represent that long value with 6 to 7 digits precision. So it will always allow. But when you are converting integer and long to a float, there is going to be precision loss. That is what is happening, right? So integer is 4 bytes, so is float, but float has only 6 or 7 bits of precision, but integer has almost 9 digits, right? So there is always going to be loss of precision. So these three conversions, like integer and long to float and long to double, there is going to be loss of precision. But we said into double it can be implicit, and there won't be any loss of precision. That is the only case you need to remember. Okay, that is all about type conversion. Go through this table, it is very easy to understand. Then also look at these examples and try with some of the values. You can change the values here and see for yourself what are the values that are going to be present after explicit type conversion. Implicit type conversion is easy, but also be careful of this implicit conversion where loss of precision is possible. Okay, you should be aware of that. And this table will simplify in a manner that you can remember it. Okay. Anyhow, please do practice, try to understand, but it is easy to remember once you understand. Okay. Thank you for watching. Please subscribe and share it with others.